go ahead and take a look at the RP versions of the 40-200 series now. So the 40-200 small, meaning 3/4 through 2 inch size, there's a cutaway showing on the screen. Check assembly is the same as we saw in the small 40-100 series, except instead of the checks being at that Y pattern angle, they're both on the top, just like on the new double checks. Here's an actual case where you can see where the replaceable check seats look like. You can see where they're sealed in by an O-ring. And same on the double check, that same basic configuration. So basically, if you cut the bottom half off, that's what their double check would look like in the 40-100 series. But the 200 series being the RP, of course, the first check having a heavier spring load. Let's go ahead and concentrate on the relief valve here, because that's what we want to talk about now that we've talked about the checks over there. So we talked about relief valves earlier, and the key things we wanted to talk about was the type of elastic element, the trip ratio on it, and whether it's hydraulically balanced or not. So here's the water path here. This is our high pressure coming in. Let's say we have 100 pounds pressure coming in from the street. Let's say we have 90 pounds pressure after that first check, just to make the math simple. And let's say after the second check, we have a 5-pound spring load to make it 85. These are just numbers for demonstration purposes, not indicative of this particular assembly, but just going through the numbers. So our 100-pound pressure comes down here through this small little area here, goes down this small little passageway on the high pressure side of our elastic element. So we have 100 pounds pressure pushing that way on our elastic element. Once that closes our relief valve seat, which sits right here, you can see in the gray right there, that disc will move over, seal against that seat, goes past the first check, builds up the area where we have the pressure in this area down here, 90 pounds. So that means I have 90 pounds pressure pushing in on the low side of our elastic element. Now, it's an important thing to notice the area of the high pressure in relationship to the low pressure sensing line. This is not something that affects in an average repair, but can change when water flows through the assembly. When an engineer first designs a backflow assembly like this, they want to make sure the relief valve, when it opens or closes, opens in a hydraulic discharge, meaning it goes from low flow to full flow gradually. In other words, they don't want the relief valve coming on, going off, on, off, constantly jerking back and forth. They want that gradual open and that gradual closing. That's got a lot to do with the sizing of the high pressure and low pressure sensing line interface. In other words, how fast water goes on and off that elastic element kind of dictates how that stem moves back and forth as the pressures change. So, knowing that, let's look at how small this little area is on this conbraco series. And this is important when we're working on the 2 inch and under, because this little area down here causes our little issues. Conbraco engineers, when they first designed this assembly, knew one of the biggest problems was dirt and debris. In other words, when dirt and debris gets caught under this check assembly right there, it's going to leak. So the engineers wanted to find a way that, okay, how can we make it so that if it does get dirt and debris but not stuck under that check assembly, that it will not affect it? Well, most assemblies that are similar to this have the body kind of go like this. There's not this lower area here. And they may have a little tube that comes down for the sensing line, something like that, on a solid body. Well, dirt and debris would line up on these spots on those other models, and as the water flowed in there, suddenly, boom, it would get caught in the first check and they'd have a check failure. So the conbraco engineer says, I've got an idea. Let's put this small little catch basin in down here so that as the water turns off and that dirt particle stops right here, instead of it sitting there till the flow of water, it drops out of the way of the water passageway. And now, when the water resumes, this can no longer be sucked into the flow of that check assembly. Not a bad idea. Helps us out quite a bit if the dirt and debris is there just when the check assembly closes. But what does putting all this dirt and debris down here do to our relief valve now? What would happen if this whole area, we had a lot of dirt and debris built up? Could it plug my high pressure sensing line right there? Sure. Could that affect the interface between the high and low pressure sensing line? Sure. What might happen is sometimes you'll see this type of relief valve jerk open and jerk close, which means sometimes that sensing line is plugged, causing it to act a little erratically. So that's why it's important to see that interface between the high and low pressure sensing line. Since we know there's a high and a low, we know that it's hydraulically balanced. We'll talk about the trip ratio in a minute. You can see the effective area of that diaphragm is here, and the relief valve orifice right there. So it's got a good trip ratio, and it's a flat diaphragm, not a rolling diaphragm. So fairly reliable relief valve, easy to see how it works here. Key things we want to talk about here in the gray right here is my relief valve seat. The relief valve seat is sealed with an O-ring. You can see the O-ring right there. Here's my relief valve disc right here that sits within this gray disc holder. I have this red piece here, my stationary spacer, which is very important in this unit. There's an O-ring, positioning O-ring right there inside of it, like this. and then my spring, and then my center of my stem right there. So this portion here travels back and forth like that, which causes my relief valve disc to hit my relief valve seat, and this stationary spacer part, as the name implies, stays stationary as the stem moves back and forth. So this is kind of a cutaway showing you what that relief valve looks like. So here's the small, meaning 2 3/4 through, or actually quarter through 2-inch 40-200 series. First thing I want to show you is the covers. Some of them you may see them tapped like this, and this is where our test cocks may be located. A lot of them you'll see where it's drilled on the side of the body here and over here where the test cocks go in also. Can make a difference on the workings of the assembly. Obviously on the side is not as critical as the ones that are on the cover. Why is that important if we had the test cocks coming out the cover like they did in some versions of this? The reason is because think about it. What if, here's my number 2 test cock here, here's my number 3, and here's my 4. We know about being careful to turn the number 2 test cock because we can see how that takes our high pressure right off that sensing line. And if that little catch basin that we discussed earlier is a problem, no water down here, relief valve is going to kick open and never close. But what happens if our check assemblies, our disc holders, first or second check, are swollen or having a lot of dirt and debris on them, or if they've been scratched because of sandpaper? And I open this test cock quickly to blow water out it. Could that suck that right into the top there? Sure, it could. What happens if I suck that cover, that disc holder all the way past that breather hole and I close that test cock? Is it possible that they could create a vacuum on that backside? Sure, possibly could, especially if anybody put grease on that check assembly right there. So that putting that grease in there can really affect the workings of that check assembly, especially when the disc holder opens all the way up against the cap where the breather is covered into the guide. So that's important to watch, and obviously more prevalent so when the test cocks are mounted on the covers of the checks. But we covered the checks pretty much when we talked about the 40-100 series, so we won't talk about those. Let's talk about the RP, the relief valve of the RP version. That's what it would look like if it was not a cutaway. So when we go to look at the relief valve, what we're going to see, and obviously a cutaway, we're going to see a full circle round-shaped relief valve cover. I'm going to go ahead and remove my bolts. Once I remove my bolts, there will be my elastic element. There's where my high-pressure sensing line comes through. It's internal, as I showed you on that cutaway. Stem comes out in one piece like this. Relief valve seat stays in the body for the average repair, but if the relief valve seat does have to be removed, they make a special tool that goes in, unscrew the relief valve seat, or a check seat, same story. If I have to change the check seat, they make a tool that fits in like this and goes in, so if I have to change that seat, that can be replaced. But let's talk about the relief valve, and I'll go ahead and show a 2-inch just because it's a little bit bigger and easier to see. Now, the 3/4 inch, the one thing on that you'll see is that mounting O-ring that holds that into the body. We'll talk about that when we put it back together. Let's go ahead and remove our relief valve disc first. There are 2 screws. This screw holds the disc retainer, and the RV disc. Turn it over. I have a second screw, and this will have my relief valve spring tension on the back side. So as I go to remove it, there will be spring tension coming up. Again, this is a 2-inch relief valve. Spring retainer, spring, our stationary guide, and our stem with our O-ring in the center. So here's what that stem assembly looks like together. Here's what it looks like in pieces. And looking at it closely, let's kind of see what's going on like that through that assembly. So the stationary spacer, as I mentioned, the name implies stays stationary. As that 100-pound pressure that we just discussed causes that stem to move, and what will happen is the stem pushes across over like that and closes on the relief valve seat. As the pressures change, it comes back and travels back and forth. In other words, stationary spacer stays still. The diaphragm, which is attached on the back side here, moves back and forth, causing the stem to move like this. Now, we talked earlier about the different properties of rubber, and you can see the color of the rubber there is that black type of rubber, that Buna N family, if you will, of type of rubbers, EPDM, nitrile, those kind of names that the black rubber is. But the thing with the black rubber that we remember from our discussion on rubber is that the black rubber reacts to different things being water quality and or temperature, and that reaction is usually a swelling. Well, think about it. If that O-ring swelled, what would happen to my relief valve opening point? In other words, my relief valve opening point is conditional on this stem moving on and off the seat. If suddenly that O-ring is tight, now it gets real tight because of a swelling action, is that going to change my relief valve opening point? Of course it is. So that's a very important part of this relief valve, is that O-ring that sits in the middle of that stem going across that stationary spacer. Very important that we lubricate it properly. Proper lubrication means out of the holder, fingers lubricate greased, and all the way around the 360-degree fashion. So rebuilding it is going to be just the reverse. We're going to replace our O-ring, our spring retainer. Go ahead and tighten our spring retainer bolt back up. Have that ready to go tight, like there. Relief valve disc retainer, relief valve screw. That's what my relief valve stem looks like. I showed you on a 2-inch one just so you could see what it looked a little easier to see. Now we'll put our 3/4 back together, a little harder to see because it's smaller. Go ahead and have that stem. We have our mounting O-ring, which sits right there on our stationary spacer. As we go to insert it in the body, basically what we've got is a blind assembly. You can see I'm shoving that in place, and I've got to hit that disc in the middle of that without damaging that seat. So I want to be careful and place it in slowly, kind of feel your way around so that now that disc sits in the middle. Now once I get the disc in there, notice what happens as I go to push it. I want to make sure the stem moves easily through its travel. I don't want to hear any galling, grinding, or any kind of noise coming as it moves back and forth. It should move that easily. Also, that's what sets my mounting O-ring right there. In other words, by here, it's not set, but as soon as I push the stem in place and stroke it once, you'll see that the O-ring falls into its slot. So now I'm ready to go ahead and line up my relief valve sensing line with my elastic element, my diaphragm. Go ahead and put my cover on. Like this. And I'm done, right? Well, maybe. Let's go back to the board and look at the cutaway of this assembly for a second. What I want to show you on the 40-200 series, and this is going to apply to not only Conbraco, but a lot of other manufacturers, is let's say these are our normal numbers that we want to see when we test that, the 100 inlet, the 90, and the 85. And let's say we went ahead and repaired it because it wasn't working properly, and we went ahead and tested it, and let's say our relief valve was a 3.5 relief valve opening point, good number. We went and tested our second check, and the second check worked okay. So we know that the second check held tight. And after we checked our second check, we took our reading on our first check, and we had a, like we see here, a 10.0. Okay? Good numbers. Checked our original factory specifications, checked our flow charts, everything we're happy with, and everything's working fine. So at this point, we start packing up our tools and leave it and thinking we're done, right? After we've disconnected our hoses and tubing, and all of a sudden we start seeing a little drip, drip, drip coming out of the relief valve. What's our first reaction? Oh, darn it, dirt and debris got in the first check again. Take it apart, clean it up, put it back together, test it again, same numbers, but we still have our same drip. Here's a case where hydraulically this assembly is working, because that's what these numbers are telling us, that this is stopping back pressure and back siphonage. But what this drip is telling us that somewhere in this assembly we've got a problem. And these are what are called nuisance drips. Nuisance drips are assemblies that are drips that we have to find somewhere in that assembly that making this assembly not work. It's working hydraulically, but making it drip. The most logical case in this scenario is this O-ring right here. Think about it. If that stem moves back and forth and that O-ring got nicked when I shoved that relief valve stem in there, couldn't water travel across there and come out? Sure it could. Where else could I get a nuisance drip on this design? What about that O-ring that sits in the middle of that stem, that sits in the middle of that stationary spacer? Water could travel out across that disc through here. So check your numbers hydraulically. Make sure the assembly's working. But if you find a drip somewhere, don't just think it has to be first check, because it could be a nuisance drip as we're talking about. And that nuisance drip could come from any mechanical seal along that portion of the relief valve, as long as we know hydraulically that assembly is working properly. So look for the usual, and the amount of leakage is directly proportional to the leak. In other words, if it's a little drip, 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 it's a little nick, nick, nick. If it's a big gush of water, O-ring's missing or something dramatic is taking place. So nuisance drips are something we have to deal with on all RPs, and this is just a good picture to show it to you where you can see it on the Conbraco 40-200 series. So looking at a cutaway of a 40-200 series assembly, we use those same numbers we did before, 100-pound inlet, 90 pounds pressure after the first check, giving us a 10-pound first check load just to make the math simple. 5-pound second check spring gives us a 5-pound differential, keep math simple. Same check mechanisms we saw in the 40-100 series. Again, check seats screw into the body, sealed by an O-ring. Disc holder comes out in one piece. The spring is contained. I have to remove the cover off the top. The spring will stay contained. We've got that same hidden O-ring that sits in the middle of that stem as we saw in the 40-100 series. What's different on this 2.5 through 10 inch size is where the relief valve is mounted. Remember on the small ones, it was a one-piece body where the relief valve was attached to the body. On the larger 2.5 through 10, the relief valve is a separate body that mounts underneath the check body. Relief valve body is bronze. Check cover is ductile iron. Relief valve assembly mounts down here. Our high pressure sensing line comes over here. Low pressure sensing line here on this side. So here's a cutaway of an actual one. Check mechanisms as we saw in the 40-100 series. Here's the relief valve version that mounts underneath. High pressure sensing line, O-ring seal on there. Low pressure sensing line, O-ring seal on the top of the relief valve body, which mounts to the bottom of the check body, as you can see right here. So checks we already did with the 40-100 series. Let's kind of take a look at the relief valve real quickly. Go ahead and remove our cover bolts. We're exposed to our relief valve elastic element, in this case a diaphragm. Our stem assembly comes out in one piece. Relief valve seat is replaceable, threads into the body like this. As you can see, sealed by an O-ring. If you'll notice that the relief valve stem looks exactly like as what we saw in the small, meaning 3/4 through 2 inch relief valves, that's because it's the exact same design. In other words, one screw holds the disc into the disc holder, like this. One screw holds the relief valve spring tension on the back side of the spring retainer. So we've got our retainer, our spring, our stationary spacer, and our stem. So a nice thing conbraco did is we've got the ability to rebuild anything from 3/4 to 10 in the 40-200 series, and the relief valve is identical throughout the size ranges. One important thing to notice though is look at the color of the O-ring on the relief valve stem in the larger sizes. Notice they went to a silicone O-ring. Earlier we talked about the properties of rubber and how the black rubber tends to have a reaction. The reaction tends to be a swelling. We know that silicone is a dimensionally stable rubber. So this rubber being dimensionally stable, theoretically, as this stem moves back and forth, we don't have to worry about the effects of swelling through its normal usage, and that's true. Another thing that's important on this particular relief valve design, the same as back to the small ones, is that the interface of the two materials, in other words, what is the relief valve guide made of, and what's the relief valve spacer made of? This is a plastic. It's a plastic called glass-filled Naril. Very hard plastic, very brittle, but very dimensionally stable. This stationary guide is not a plastic at all. It's actually a piece of brass that's epoxy coated. Again, more dimensionally stable than any type of rubber or plastic material that may or may react to pressure, temperature, or other conditions. So the dimensional stability of this relief valve is increased dramatically by having the hardened guide, the hardened plastic, and going to the silicone rubber on the relief valve. Here's a case where if you had a softer plastic on the stationary spacer or a softer plastic on the guide, you could expect it to react, and that reaction being a swelling in most cases, where it could change the interface of the workings of that relief valve. But anyway, reassemblies just like the small ones. Go ahead and take it apart. Put it back together. Put our stem in the middle, stationary spacer, relief valve spring, spring retainer bolt. Tighten that back up. Relief valve disc retainer, a relief valve retainer screw, my mounting O-ring, mounting my stem in place. Same as in the small one, cycle it back and forth, make sure it's working properly. Line up my relief valve sensing line, my relief valve cover, so that my sensing line going from the relief valve appropriately. And that's the 40-200 series, 2.5 through 10. The next series in the conbraco series is the 40-500 series, or PVB40 series may be on them also. So pressure vacuum breaker production began in 1991, was discontinued in 2003. It was a bronze body unit. Here's a breakdown showing the PVB canopy on the top, 2 canopy screws, bonnet assembly that unscrewed from the top, bonnet O-ring, air inlet spring, air inlet stem. This part was assembled into the bonnet. Poppet assembly with the air inlet disc, spring retainer, spring, the check assembly, and here's the breakdown disc holder, disc retainer, a guide, and guide screw. 2 test cocks that screw into the side of the body. That's the 40-500 series. Let's see what it looks like inside. This is a 3/4 inch without the shutoffs. 2 test cocks mounted on the body over here. Canopy on the top. 2 screws hold the canopy on top. I want to emphasize the point that this canopy is an important part of this assembly. A lot of times this ends up holding keys and change inside people's trucks, and they don't want to put it back on when they're done with their test, and they say it's not important. It's very important. Some people consider it just a splash guard where it diverts the water when you turn the ball valves on. That's not true. It also keeps things from falling inside the Backflow body itself. Anyway, to go ahead and disassemble the 40-500 series, the bonnet assembly will unscrew from the top. It has an O-ring seal underneath. Bonnet will come off, one piece. The spring load for the air inlet is set at the factory, and that pin goes in here. The next thing I'm going to pull out is my poppet assembly. And here is my air inlet disc, which stretches in and out of the disc holder like this. Reassembling is going to be just the reverse. And very important when you put this back together to make sure that that disc is all the way into the holder, because it's very easy for it to be slightly elongated on one side and not be in there. It usually requires a twisting action like that to get it completely set. Check mechanism what causes a lot of problem on this. If you look up close here, you'll see that this piece right here has 4 little knobs on it. There's 2 here, and over there. This is the spring retainer that holds that spring into the body. So you have to push down on that retainer, rotate it 90 degrees, which allows you to flip up one end, bringing it up from the top like this. Spring holds the check disc holder and comes out in one piece like this. Check seat's cast in the body and not replaceable. One screw holds the disc into the disc holder. That's easy to change. Put my spring back on. Now I have to reassemble. And here's the part you want to see up close to kind of look at, because how this goes back in the body is important. Obviously, we don't have the side view of this cutaway that we will out in the field. So we're going to go ahead and put our check assembly back in place. I'm going to cheat. There we go, like that. Now the purpose of the spring retainer is to push perfectly flat down on that spring. Notice that it's a cone-shaped, not a cylindrical compression spring. So we know cone-shaped springs have a tendency to fatigue a little faster than the compression springs. So how this spring retainer pushes down on it is very critical, because it has to be pushing down perfectly straight. As I said earlier, there's 4 little knobs on each corner of that spring retainer that you see here, and they have to sit underneath this lip right here and right over here. So we put the spring retainer in from the top, pushing down. Rotating at 90 degrees. Now we want to get that spring retainer just like that, so it's sitting perfectly flat underneath that lip right there. You see the little ridge right there and the flat part sitting under there. That has to happen on both sides just like that, so that it's giving a perfectly flat compression on that spring, giving the optimum spring load. Once that's in place, then the poppet goes in next. Our bonnet assembly, like this, O-ring seal on the top. Go ahead and tighten that down. Canopy. That's our 40-500 series of pressure vacuum breaker.